Assalamu alaikum, brothers and sisters. Welcome to the journey of quest where we quench your thirst of knowledge. Ever wonder what happens when two different types of magma meet? The answer might surprise you. Magma, that molten rock beneath Earth's crust, is much more than just a hot, fiery substance. It's a key player in the grand theatre of geological processes, birthing new landforms and shaping our planet's dynamic landscapes. Now imagine two distinct types of this molten rock, each with their unique chemical compositions and temperatures, encountering each other. What transpires then? You might be tempted to think it's as simple as mixing two types of soup, but magma, with its complex chemistry and high temperatures, doesn't play by our everyday rules. The phenomena of magma mixing, mingling, and interestingly, immiscibility come into play. These interactions not only influence the characteristics of the resulting rock, but also have profound implications on volcanic activities. So buckle up as we delve into the fascinating world of magma interactions. Imagine two bodies of magma with different temperatures and compositions coming into contact. What happens next is a geological dance known as magma mixing. Now let's unravel the steps of this dance. When two magmas meet, they don't just blend together like a simple cocktail. No, they engage in a much more complex interaction. Picture this: one magma is hotter and less viscous, while the other is cooler and thicker. The hotter magma, with its lower viscosity, can easily penetrate and envelop the cooler magma, creating a swirl of contrasting compositions. This is the initial stage of magma mixing, and it's just the beginning. The next phase is the homogenization stage. As the two magmas continue to interact, they start to merge their unique characteristics. Elements from each magma begin to dissolve into the other, leading to a more uniform or homogeneous mixture. This process isn't instantaneous, it takes time, and the rate at which it happens depends on several factors such as the temperature difference between the two magmas, their initial compositions, and even the pressure conditions. Now you might be wondering, why does all this matter? Well, the process of magma mixing significantly influences the characteristics of the resulting rock. The mixing of magmas, with their differing mineral compositions, can give rise to a wide array of igneous rocks. For instance, the mixing of basaltic and rhyolitic magmas can produce andesite, a rock with intermediate characteristics. This diversity in rock types is one of the reasons our planet's crust is so varied and fascinating. Moreover, magma mixing can also influence the eruption style of a volcano. A more viscous magma mixture can lead to more explosive eruptions, while a less viscous one might result in gentler, effusive eruptions. So magma mixing isn't just a geological phenomenon happening miles beneath our feet, it's a dynamic process that shapes the Earth's crust, influences volcanic activity, and contributes to the rich diversity of rocks we see around us. So magma mixing is a complex process that significantly impacts the nature of igneous rocks. Now, what if I told you that sometimes magma doesn't mix but mingles instead? Yes, you heard me right. Magma can be quite the social butterfly at times. This is a process known as magma mingling, and it's as fascinating as it sounds. Let's paint a picture. Imagine two distinct magmas, each with its own unique composition, temperature, and viscosity. When they meet, you might expect them to mix together, creating a completely new magma. That's what we discussed in the last scene, but magma mingling is a different story. Instead of mixing, these two magmas maintain their individual identities, like oil and water. They remain distinct but influence each other, producing a composite magma with characteristics of both. This process can occur when the two magmas have similar viscosities but different temperatures or compositions. It's a delicate dance, a mingling of two distinct entities, resulting in a unique creation. The implications of magma mingling are vast and fascinating. This process enriches the diversity of magmas and subsequently the rocks they form. It's like being at a potluck dinner where everyone brings a dish to share. Each dish retains its unique flavor, but together they create a diverse and delightful meal. That's what magma mingling does to the world of geology. It adds variety and complexity to the formation of rocks. This mingling process can also lead to the formation of composite magmas, which can produce a variety of rock types, including some of the most explosive and destructive volcanoes known to humankind. These composite magmas are a testament to the power and complexity of our planet's inner workings. So the next time you see a beautifully patterned rock, remember it might be the product of a unique mingling process deep beneath the Earth's surface. a process where two distinct magmas met, mingled, and created something entirely new, yet beautifully complex. Thus, magma mingling offers a unique and intriguing perspective on the behavior of magma. But what happens when magma just won't mix, no matter what? Welcome to the concept of magma immiscibility. In the world of geology, immiscibility is a term that describes the inability of two substances to mix together. It's like trying to mix oil and water. No matter how much you shake them, they just won't blend. Now, apply that same concept to magma, and you have magma immiscibility. You see, magma is not just one uniform substance. It's a complex mixture of molten rock, minerals, and gases. And just like oil and water, sometimes different types of magma just refuse to mix together. This is caused by differences in temperature, pressure, and composition. Imagine two magmas, one rich in silica and the other rich in iron and magnesium. When these two come into contact, the silica-rich magma, being less dense, will rise to the top, while the iron and magnesium-rich magma will sink. This separation is the result of magma immiscibility. But what effect does this have on the resulting magma and rock? Well, the separation of these two types of magma can lead to the formation of different types of igneous rock. For instance, the silica-rich magma might form a light-colored granite, while the iron and magnesium-rich magma could form a dark-colored basalt. This phenomenon also has implications for the formation of various ore deposits. Certain precious metals and minerals can concentrate in one of the immiscible magmas, leading to the formation of rich ore bodies. But under what conditions does magma immiscibility occur? Typically, it happens under high pressures and temperatures deep within the Earth's crust. The exact conditions, however, can vary widely depending on the specific types of magma involved. To sum it up, magma immiscibility is a complex process, and it's one of the many factors that contribute to the rich diversity of our planet's geology. It's a testament to the dynamic and ever-changing nature of the Earth's interior. So magma immiscibility is another fascinating aspect of magma behavior that can dramatically alter the nature of igneous rock. So we've seen that magma can mix, mingle, or become immiscible. But what does this all mean for geology? Well, let's take a step back and quickly recap. Magma mixing is when two or more magmas with different compositions come together and form a new homogeneous magma. It's a bit like mixing different colors of paint to create a new shade. Magma mingling, on the other hand, is when magmas with different compositions coexist without completely blending. It's more like oil and water in a salad dressing, existing side by side but maintaining their separate identities. Immiscibility, that's a bit different. This is when a single magma separates into two immiscible phases. Much like oil separating from vinegar in that salad dressing, each phase retains its unique composition and can solidify into distinct types of rock. These interactions aren't just interesting for their own sake. They have profound implications for our understanding of geological processes and the formation of different types of igneous rock. Magma mixing can lead to new types of magma with unique characteristics that might be quite different from the parent magmas. Magma mingling can create a mosaic of different rock types in a single location, leading to complex and fascinating geological formations. And immiscibility, well, that can lead to the formation of ore deposits. These are concentrations of valuable minerals that can be economically extracted. So, understanding magma immiscibility can have very practical implications, like helping us find new sources of precious metals. In essence, the interactions of magma beneath the Earth's surface are a key piece in the geological jigsaw puzzle. Understanding them helps us decipher the story of our planet's past and predict its future. And that's pretty cool, isn't it? We're not just studying rocks and magma. We're piecing together the history of our world and maybe even getting a glimpse of what's to come. Thanks for watching us share our videos. Subscribe our YouTube channel and press the bell icon and stay curious for new uploads.